Hello! I'm so glad you found your way here tonight. Before we begin our journey, I want you to take a moment to truly settle in. Adjust your pillow, pull your blankets up to where they feel most comforting, and let the weight of your body sink into the mattress. Tonight, we are going to explore a force that is as ancient as the universe itself, yet as modern as the room you are lying in right now. It is a quiet exploration of the invisible energy that powers our world, electricity. If you find this peaceful space helpful for your rest, I invite you to gently like this video or subscribe to the channel. It is a small, quiet way to ensure we can continue these journeys together. But for now, there is nothing left for you to do but listen. Let your eyes close if they haven't already, and let the outside world fade into a soft, distant hum. Electricity often feels like magic. We flip a switch and light fills a room. We plug in a device and it hums to life. But beneath that convenience lies a beautiful, rhythmic dance of nature. At its very core, electricity is simply the movement of tiny particles. These particles are called electrons. They are so small that billions of them could fit on the head of a pin, yet they carry the power to light up entire cities. Imagine these electrons not as sparks or bolts, but as a gentle, steady stream, like water flowing through a long, winding garden hose. This flow is what we call an electric current. It is a constant, patient movement, a transfer of energy from one point to another. It exists in the wind, in the earth beneath us, and even in the very cells of your body as you drift toward sleep. To understand how these tiny electrons begin their journey, we have to look much closer than the wires in our walls. We have to travel deep into the heart of matter itself. Everything you see around you, the wood of your headboard, the cotton of your sheets, the air you are breathing so deeply right now, is made of incredibly small building blocks. These are the atoms. They are the foundation of everything in existence, and within these tiny, silent structures, the story of electricity truly begins. In the stillness of the atomic world, there is a perfect rhythmic order, a microscopic solar system that has been spinning since the dawn of time, waiting for us to notice its quiet strength. Imagine, if you will, the center of this tiny world. At the heart of every atom lies the nucleus, a dense and silent core that acts as the anchor for everything else. Within this nucleus, we find two types of particles living in a peaceful, heavy stillness. First, there are the protons. Each proton carries what we call a positive charge, a soft, inviting internal signature that acts as a beacon. Beside them are the neutrons, which, as their name suggests, are perfectly neutral. They carry no charge at all. They simply add weight and stability, sitting like quiet stones in a garden, ensuring the center of the atom remains firm and grounded. But the true magic happens in the vast, open space surrounding that core. Here we find the electrons. These are the particles that carry the negative charge, and they are in a state of constant, rhythmic motion. To visualize an atom is to visualize a microscopic solar system operating with the precision of a masterfully crafted clock. Just as the Earth and the other planets orbit the Sun, held in place by the invisible pull of gravity, these electrons orbit the nucleus, held in place by the invisible pull of electromagnetic attraction. The positive charge of the protons reaches out to the negative charge of the electrons, creating a delicate, shimmering bond that keeps the entire structure in balance. This concept of charge is a fundamental property of the universe, much like mass or volume. It is an inherent part of what makes matter, matter. In this quiet, subatomic world, there is a simple rule that governs everything. Opposites attract, and likes repel. Two positive charges will gently push away from one another, as will two negative charges. But a positive and a negative have a deep, natural affinity. They seek each other out, longing to find a state of perfect equilibrium. It is this constant seeking of balance, this invisible tug-of-war, that creates the potential for all the energy we use. As you lie there, it is fascinating to consider that the solid objects around you are mostly made of empty space. If an atom were expanded to the size of a vast football stadium, the nucleus would be no larger than a small marble placed right in the center of the field. The electrons would be like tiny gnats, buzzing far away in the very highest rows of the stands. Everything in between is simply a quiet, invisible field of energy. This means that you, your bed, and the very air in the room are composed of these wide, airy structures held together by the rhythmic dance of these tiny, charged particles. In most things we touch, the atoms are perfectly balanced, with an equal number of protons and electrons, keeping everything calm and neutral. But sometimes this balance is nudged. In certain materials, the electrons in the outermost orbits are held very loosely, like a leaf resting on the surface of a still pond. They are ready to move, waiting for the slightest invitation to leave their home atom and journey to another. When these charges begin to shift and move between objects, the quiet world of the atom begins to interact with the world we can see and feel. This simple migration of electrons is the spark of discovery that ancient civilizations first noticed in the most unexpected places. Long before we had wires, switches, or glowing bulbs, there was a golden, translucent stone known as amber. To the ancient world, this was a material of great beauty, fossilized resin from prehistoric trees, often washed up on distant shores like a gift from the sea. It was through this beautiful, honey-colored stone that humanity first glimpsed the invisible force we now call electricity. Around 600 years before the Common Era, the Greek philosopher Thales of Miletus observed something remarkable. He found that if he took a piece of amber and rubbed it vigorously with a soft cloth or a bit of animal fur, the stone seemed to undergo a subtle transformation. It developed a strange, quiet pull. If he held the rubbed amber near a lightweight object, perhaps a stray piece of straw, a tiny bird feather, or a bit of dried papyrus, the object would suddenly lift off the table and cling to the stone, as if drawn by an invisible thread. This was the very first recorded encounter with what we now understand as static electricity. The ancient Greeks did not yet know about electrons or atomic structures, but they were so moved by this phenomenon that the legacy of their discovery is woven into our language today. The Greek word for amber is electron. When scientists in later centuries began to formalize the study of these mysterious attractions and sparks, they looked back to that golden stone and named the force electricity in its honor. What Thales was doing, in the simplest terms, was moving particles. The friction of the cloth against the amber was physically stripping electrons from one surface and depositing them onto the other. This created an imbalance, a surplus of negative charge on the amber. Because nature always seeks a state of balance, The amber reached out to the neutral objects around it, trying to bridge the gap. It was a tiny domestic version of the same force that powers the stars, happening right in the palm of a hand. As you listen to this, take a moment to notice the quiet around you. Just as the amber was wrapped in cloth, feel the gentle weight of your own blankets draped over you. Notice the softness of the fabric and the way it holds your warmth close to your body. Allow your shoulders to drop an inch further into the mattress. There is no friction here, no effort required. You are simply existing in a state of rest, much like the amber when it is set back down on a shelf, its brief energy subsiding into the stillness of the room. For centuries after Thales, electricity remained a curiosity, a fleeting, temperamental thing. It was static, a word that means standing still. It could produce a sudden bright spark or a soft crackle, but it was always gone in an instant. It was a burst of potential that vanished as quickly as it appeared. The great challenge for the thinkers who followed was to find a way to make this power stay. They began to dream of a steady, reliable stream of electricity, not a sudden jump, but a rhythmic, continuous flow that could be harnessed and directed. This transition from the sudden spark of the amber to the steady hum of a constant current would require a new way of thinking about energy, leading us toward the very first inventions that could store the power of the universe in a simple, quiet jar. For thousands of years, electricity was like a wild, flickering light, seen only in the sudden flash of a storm or felt in the quick snap of a spark against silk. It was powerful, but it was fleeting, a ghost that vanished the moment it was touched. To make it useful, we had to learn how to tame it, how to make it flow like a gentle stream rather than a sudden flood. This breakthrough arrived in the year 1800 within the quiet, candle-lit laboratory of an Italian physicist named Alessandro Volta. Volta did something remarkably simple, yet it changed the world forever. He took small, circular discs of two different metals, zinc and copper. He began to stack them one on top of the other, alternating the metals in a tall, steady column. Between each pair of metal discs, he placed a small piece of cardboard or cloth that had been soaked in salt water, or brine. This stack became known as the voltaic pile. In the stillness of his study, as the moonlight perhaps spilled across his workbench, a transformation was taking place. A chemical reaction was occurring between the metals and the salt water. This reaction acted like a gentle pump, pushing electrons from the zinc toward the copper, over and over again. Unlike the amber, which gave up its charge in a single quick burst, this pile produced a steady, continuous, and reliable stream of electricity. It was the world's very first battery. Think of the silence of that room. There were no buzzing machines back then, no humming computers. There was only the soft ticking of a clock and the invisible, silent movement of energy through a thin wire. It was a rhythmic pulse, a heartbeat of power that didn't fade away. This steady pressure of electricity is what we now call voltage, named in honor of Volta himself. Every time you look at a battery or see the word volt, you are hearing a whisper of that first quiet victory over the chaotic spark. This was the birth of chemical potential energy. Within that stack of metal and salt, energy was being stored, tucked away safely within the bonds of the atoms. It was waiting, held in a state of readiness, like a deep breath held before a soft sigh. It is a comforting concept, the idea that energy can be gathered and kept still, resting in a container until the moment it is invited to move. As you lie there, you might think of your own body in a similar way. You have spent the day moving and acting, and now that energy is being stored and replenished. You are like a battery being gently topped up by the stillness of the night. Your potential for tomorrow is being gathered right now in the quiet of your rest. When the current finally flowed out of Volta's pile, it needed a path to follow. It needed a way to travel from one point to another without losing its strength or wandering into the air. This requirement led scientists to discover that not all materials are created equal. Some materials act as wide, welcoming highways for this flow, while others stand as soft, firm barriers, keeping the energy exactly where it belongs. Understanding these paths is the next step in seeing how we brought the power of the laboratory into the very walls of our homes. Imagine, if you will, the wire that leads from a lamp to the wall. To our eyes, it is a simple, flexible cord, often wrapped in a soft layer of plastic or rubber. But inside that casing lies a hidden world of movement. This is the world of conductors and insulators, the two different ways that matter interacts with the flow of energy. In the heart of that wire, there is usually a strand of copper. Copper is a remarkable material, chosen for its generosity. At the atomic level, its electrons are not held tightly to their centers. Instead, they are like travelers on a wide, open highway, ready to move at the slightest nudge. In a piece of copper, the outermost electrons are shared in a vast communal pool. Because they are so free to wander, they can carry energy from one end of a wire to the other with incredible ease. It is a smooth, frictionless glide, a silent river of potential flowing through the metal. This is why we call it a conductor. It conducts, or leads, the energy along its path. But a highway is only safe if it has guardrails. Without a way to contain this flow, the electricity would scatter, seeking any path it could find to reach the ground. This is where insulators come in. Materials like rubber, glass, and wood are the opposites of copper. Their atoms are very protective of their electrons, holding on to them with a firm, steady grip. They do not allow the current to pass through them. They are like soft, firm barriers that say, "Stay here." Think of the rubber coating on a charging cable. It acts as a comforting, protective sleeve. It keeps the energy tucked away inside the copper, moving exactly where it needs to go, while the outside remains cool and safe to the touch. It is a beautiful balance, the freedom of the conductor and the protection of the insulator, working together in perfect harmony. In the quiet of your room, there are dozens of these silent paths hidden within the walls, all of them wrapped in their protective layers, keeping the power focused and the environment peaceful while you rest. We have seen how these materials allow electricity to travel and how chemical reactions can give it its first push. But for a long time, the world relied on these small, steady batteries. To power a whole city, or even a single street, we needed a way to create electricity on a much larger scale. We needed to find a way to turn physical movement, the turning of a wheel, the flow of water, or the gust of a wind, into that silent electrical flow. The secret to this transformation was hidden in a strange, invisible force that had been known for centuries but never fully understood. It was the mystery of the magnet. As scientists began to play with wires and compasses, They noticed a peculiar dance. Whenever electricity moved, something else happened in the air around it. A phantom pull that could move a needle without touching it. This invisible connection between movement, magnetism, and light would soon change everything, opening the door to a new way of generating the energy that lights up our nights. Imagine for a moment the world as it was in the early 19th century. Science was often conducted on small wooden tables in quiet rooms, lit by the flicker of a candle. In the year 1820, a Danish scientist named Hans Christian Ørsted was preparing for a lecture, surrounded by the simple tools of his trade: a battery, a length of wire, and a small compass used for navigation. As he connected the wire to the battery, something unexpected happened. Something so subtle that a less observant person might have missed it entirely. The compass needle, which had been pointing steadily toward the magnetic north, gave a sudden, gentle twitch. It didn't move because of a breeze or a vibration in the floor. It moved because the electricity flowing through the nearby wire had reached out across the empty space and nudged it. This moment was the first time a human being had witnessed the invisible dance between electricity and magnetism. Before this, people thought they were two completely different forces of nature, as unrelated as the rain is to the wind. But that tiny twitch of the needle whispered a different story. It revealed that whenever electricity flows, it creates a magnetic field around it. It was as if the wire had suddenly become a magnet itself, projecting an invisible influence into the air. When Ørsted disconnected the battery, the needle settled back to its peaceful rest. When he reversed the flow, the needle swung the other way. To understand this, try to visualize the air around a wire carrying a current. To our eyes, it looks perfectly still and empty. But in the world of physics, the space is alive with a beautiful rhythmic structure. As the electrons glide through the metal, they generate a magnetic field that spirals around the wire like a soft, transparent vine. These are called lines of force. They are like ripples on a perfectly still pond, spreading out in silent, concentric circles. These fields are everywhere, overlapping and intersecting in the rooms where we sleep and the streets where we walk, yet they never make a sound. They are a part of the hidden geometry of our universe. This discovery opened a door to an even more profound truth. We eventually realized that these electromagnetic fields are the very substance of light itself. Every beam of moonlight that filters through your window, every soft glow from a distant star, is a wave of electricity and magnetism traveling together through the vastness of space. They support one another, pulsing in a perfect, eternal rhythm. It is a comforting thought. The same quiet power that flows through the wires in your walls is woven into the very light that illuminates our world. Ørsted's discovery showed us that electricity could create magnetism, changing the way we look at the invisible world. But it also raised a beautiful, symmetry-seeking question. If electricity could create a magnetic field, could a magnetic field be used to create electricity? Could we capture this invisible dance and use it to generate power without the need for chemical batteries? This question began to hum in the minds of the world's greatest thinkers. It would take a man of great patience and observation to find the answer. A man named Michael Faraday was about to step into his laboratory to explore this mystery, leading to a breakthrough that would eventually allow us to power entire civilizations with nothing more than the movement of a magnet. Michael Faraday was a man of immense patience and quiet observation. In the 1830s, working in the hushed, wood-paneled laboratories of the Royal Institution in London, he began to experiment with the relationship Ørsted had uncovered. If electricity could create magnetism, Faraday was certain the reverse must also be true. He spent years trying to prove it, often sitting in near total silence, watching his instruments for the slightest sign of life. For a long time, nothing happened. He would place a magnet near a coil of wire and wait, but the electrons remained still. They refused to move. But one day, Faraday realized the secret wasn't in the presence of the magnet, but in its movement. He discovered that when he physically pushed a magnet through a loop of wire, or pulled it away, a pulse of electricity was born. It was as if the magnetic field, as it moved through the space occupied by the wire, gave the electrons a gentle, invisible nudge, encouraging them to flow. This phenomenon is known as electromagnetic induction. It is a beautiful symbiotic relationship. A change in a magnetic field induces an electric current, and that current, in turn, carries energy across the distance. Imagine Faraday in his dim laboratory, moving a simple bar magnet in and out of a copper coil. With every pass, a needle on his galvanometer would sway back and forth, mirroring his rhythmic motions. It was a slow, steady pulse, like a heartbeat. This simple discovery changed everything. It meant that we no longer had to rely on the slow chemical reactions of batteries to produce power. Instead, we could generate electricity simply by creating motion. If we could find a way to keep a magnet moving near a wire, we could create a continuous, flowing stream of energy. This principle of induction is the very foundation of almost all modern power. Whether it is a giant generator in a distant power plant or the tiny components inside your favorite devices, the dance between magnets and wires is what keeps our world illuminated. It is a concept that feels almost like magic, yet it is as reliable as the turning of the earth. As we ponder this invisible dance of fields and wires, take a slow, deep breath. Notice the stillness of the room around you. There is a profound peace in understanding how the world works while you simply rest. Feel the weight of your shoulders sinking into the mattress, and let the quiet rhythm of your own breathing settle into a steady, easy pace. The world outside is powered by these same rhythmic movements, a vast and coordinated effort to bring light and warmth into our homes. Faraday's small handheld experiments eventually grew into something much larger. Engineers realized that if they could use the forces of nature to move those magnets for us, we could generate electricity on a scale never before imagined. They began to look at the world around them, at the wind, the sun, and the great heavy flow of our rivers, searching for a source of constant motion. This led us from the quiet, solitary laboratory out into the wide landscapes of our planet, where we learned to capture the energy of the Earth itself. We realized that the weight and power of falling water could be the key to turning the great turbines of the future, transforming the natural journey of a river into the silent current that powers our lives. Imagine a wide, deep river, its surface smooth and dark as it flows toward a distant ledge. This is the beginning of the journey for hydroelectric power, perhaps the most graceful way we have learned to capture the Earth's natural rhythms. At its heart, hydroelectricity is simply the science of weight and movement. We take the immense, heavy pressure of falling water and invite it to do a bit of work for us as it makes its way back to the sea. In a hydroelectric dam, the water is held at a great height, possessing what scientists call potential energy. It is energy waiting to happen, held back by the massive, curved walls of the dam. When a small portion of that water is allowed to flow through a pipe, called a penstock, gravity pulls it down with incredible force. As it falls, that potential energy transforms into kinetic energy, the energy of motion. At the bottom of its journey, the water meets the blades of a turbine. Think of the turbine as a modern, sophisticated version of an old-fashioned water wheel. As the heavy, rushing water pushes against the blades, it forces the turbine to spin. This spinning motion is exactly what Faraday discovered was necessary. Attached to the turbine is a long shaft that leads to a generator, where giant magnets are spun inside massive coils of copper wire. The weight of the river, pulled by the gravity of the Earth, provides the physical force needed to induce that steady, reliable flow of electrons. There is a profound sense of balance in this process. The water is not consumed or changed. It is merely passing through. After it has turned the turbine, it is released back into the riverbed below, often cooler and more full of oxygen than it was before, continuing its long journey toward the ocean. It is a cycle that is powered, ultimately, by the sun. Consider for a moment the vastness of the water cycle. The sun's warmth beats down on the oceans, turning liquid water into invisible vapor that rises high into the atmosphere. This vapor gathers into soft, heavy clouds that drift over the land, eventually cooling and falling as rain or snow upon the mountain peaks. This is nature's way of lifting billions of tons of water high into the air, effectively charging the landscape with potential energy. Every raindrop that falls on a high ridge is a tiny bit of stored power, waiting for gravity to pull it back down. As you listen to the thought of this constant rhythmic cycle, take a slow, deep breath. Imagine the sound of a distant waterfall, a steady, white noise that masks all other sounds. It is a persistent, soothing roar that speaks of endless energy and the reliable laws of physics. Feel the coolness of the mist on your skin and let your body settle further into the stillness of your bed. The world is full of these heavy, powerful movements, yet they happen with a consistency that is deeply comforting. The hydroelectric plant itself often sits in a quiet valley, its deep, resonant hum blending with the sound of the wind in the trees. Inside, the great turbines spin with a precision that belies their massive weight, turning the ancient pull of gravity into the light that glows softly in your home. It is a testament to how we can work in harmony with the Earth's own systems, using the weight of the rain and the height of the hills to create something clean and enduring. But water is not the only fluid that moves across our planet, carrying energy in its wake. Above the rivers and the dams, the very air itself is in constant, restless motion. Just as we have learned to capture the weight of the falling stream, we have also looked to the sky, finding another way to turn those giant magnets and harvest the invisible power of the breeze. The air around us is never truly still. Even on the quietest nights, there is a gentle migration of molecules, a slow motion tide of the atmosphere, moving from one region to another. This is the wind, a vast, invisible river of kinetic energy that blankets the entire planet. Just as we have learned to capture the weight of falling water, we have also found ways to harvest the restless motion of the air, turning the invisible breeze into a steady stream of electricity. Imagine yourself standing in a wide, open landscape at dusk. The ground is covered in soft, swaying grasses, and the sky above is a deep, tranquil violet. On the horizon, you see the tall, slender forms of wind turbines. They are painted a soft, matte white, designed to blend into the hazy clouds. Their long, elegant blades move with a slow, deliberate grace, tracing giant circles against the darkening sky. There is something deeply meditative about their rhythm, a persistent, circular motion that seems to synchronize with the very heartbeat of the Earth. These blades are marvels of quiet engineering. They are not merely flat surfaces for the wind to push against. They are sculpted with the same precision as the wings of a great bird. As the wind flows over them, it creates a subtle difference in air pressure. This creates a gentle force called lift, which coaxes the massive blades into their slow, steady rotation. Even a light breeze, one that might only softly rustle the leaves of a tree, contains enough kinetic energy to begin this process. Inside the housing at the top of the tower, hidden away from the elements, this slow rotation is transformed. The main shaft, turned by the blades, enters a gearbox that steps up the speed, turning a smaller, faster shaft that enters a generator. Here, the same beautiful principle of induction takes place. Magnets spin within coils of copper, and the mechanical energy of the wind is converted into the electrical potential that powers our lives. It is a clean, silent exchange, a way of catching the wind without ever slowing it down for long. As you listen to the idea of these great blades turning, take a moment to notice your own breathing. Let it become slow and rhythmic, much like the rotation of those white sails in the sky. With every inhale, imagine the cool, fresh air moving across the landscape. With every exhale, feel your body becoming heavier, more settled into the softness of your bed. The world outside is wide and full of movement, yet here, in this space, everything is still and safe. The sound of a wind turbine is often described as a soft, rhythmic whoosh, a low-frequency pulse that can be as soothing as the sound of distant waves hitting a sandy shore. It is a sound of harmony, of technology working in step with the natural world. These turbines reach high into the sky, often hundreds of feet up, to catch the steadier, more powerful winds that move far above the friction of the ground and the obstacles of the city. Up there, the air flows in long, uninterrupted currents, carrying the energy of distant storms and sun-warmed plains. But why does the wind blow at all? It is, at its heart, a response to the warmth of the sun. The sun heats the earth unevenly, warming the equator more than the poles, and the land more quickly than the sea. This creates pockets of warm air that rise upward, leaving behind a space that cooler, heavier air must rush in to fill. In this way, the wind is a messenger, carrying the story of the sun's warmth from one place to another across the globe. As we watch the blades turn, we are really observing the sun's influence at work through the medium of the air. It is a reminder that almost all the energy we use is a gift from the stars. And while the wind is a powerful and graceful ally, we have also found a way to gather that same solar energy even more directly. We have learned to look past the movement of the air and the flow of the water, turning our attention instead to the very particles of light that travel through the vacuum of space to reach our world. This light carries a quiet, potent energy that requires no moving parts at all to harvest. Only the stillness of a clear day and the steady arrival of the sun's rays. Imagine, if you will, the sun hanging in the vast velvet silence of space. It is a constant glowing hearth, sending out streams of light in every direction. This light is composed of tiny, weightless particles called photons. Each photon is a little bundle of pure energy, traveling at the fastest speed possible in our universe, about 186,000 miles per second. It takes only 8 minutes for a photon to leave the surface of the sun and reach our world. When you step outside on a clear day and feel the sun's warmth on your skin, you are feeling the gentle impact of millions of these photons arriving after their long journey. To capture this energy, we use something called a photovoltaic cell, the building block of the solar panels you see on rooftops or in wide, quiet fields. The word photovoltaic simply means light electricity. These cells are most often made of silicon, a material that is found in abundance in common sand. Inside the cell, the silicon is arranged in thin layers, like a delicate sandwich. When a photon from the sun strikes an atom in the silicon, it acts like a tiny, invisible bell being rung. The energy of the light is just enough to nudge an electron away from its home atom, knocking it loose. Because the solar cell is designed with specific electrical properties, these displaced electrons are encouraged to move in a single, unified direction. They cannot simply wander. They are guided into a flow. This quiet, steady march of electrons is a direct current of electricity, born from nothing but light and stillness. Unlike a coal plant or a wind turbine, a solar panel has no moving parts. There are no gears to grind, no steam to hiss, and no blades to whir. It is a form of power generation that is as silent as the light itself. As you consider the peaceful nature of solar energy, take a moment to notice the warmth of your own bed. Perhaps you can feel the heat trapped beneath your blankets, creating a small, cozy climate just for you. This warmth is a comfort, much like the golden light of a late afternoon sun slanting through a window. Let that feeling of warmth spread from your shoulders down to your toes. Imagine yourself as a solar cell, perfectly still, simply absorbing the quiet energy of the room. You don't need to do anything or go anywhere. You are merely resting, letting the world outside carry on with its busy rhythms, while you remain in this pocket of calm. While solar panels and wind turbines are wonderful ways to gather energy from the environment, they are only the beginning of the journey. A single panel on a roof or a single turbine on a hill is a small source. But our world requires a massive, coordinated effort to keep the lights glowing. To manage this, we have created one of the largest and most complex machines ever built by human hands: the grid. The grid is a vast, interconnected web that spans entire continents, linking every power source to every home and business. It is a living network that must be perfectly balanced at every moment of the day and night. But before the grid could become the silent backbone of our civilization, there was a great debate about how electricity should actually travel. This period of history was a quiet but profound turning point. A time when two different visions of the future competed to decide how the world would be powered. It was an era that would eventually lead to the humming wires that stretch across our landscapes today, carrying the breath of the wind and the fire of the sun into the very walls of your home. In the quiet years of the late 19th century, as the first electric lights began to flicker in the windows of city homes, a choice had to be made about how that light would travel. This period of history is often remembered as the War of Currents, but in the stillness of the night, we can see it as a thoughtful search for the best way to share energy with everyone. On one side was Thomas Edison, a man of immense practical wisdom, who championed direct current, or DC. In a DC system, the electrons flow steadily and faithfully in one single direction, much like a calm river moving toward the sea. It was a beautiful, simple concept, and it worked perfectly for small areas. However, DC had a gentle limitation. It couldn't travel very far. As the electricity moved through the wires, it would slowly lose its strength, turning into heat instead of light. To power a whole world this way, we would have needed a power station on every other block, a constant hum of machinery in every neighborhood. On the other side of this quiet debate was Nikola Tesla, a man who thought in terms of rhythms and waves. He proposed alternating current, or AC. In an AC system, the electrons do not move in a straight line. Instead, they shift back and forth, changing direction 60 times every second in a steady, pulsing beat. This might sound more restless, but this rhythmic motion allows the electricity to be stepped up to very high pressures or voltages. By doing this, the energy can glide across hundreds of miles of wire with almost no effort, losing very little of its power along the way. It was as if Tesla had found a way to make the electricity weightless, allowing it to soar over mountains and through valleys to reach even the most remote farmhouse. Eventually, the efficiency of AC current won the day. It allowed us to build power plants far away from where people lived, near great waterfalls or in windy plains, and send that energy silently across the distance. This decision is why our world looks the way it does today. It is why the electricity in your walls is pulsing with that same 60-cycle rhythm Tesla envisioned over a century ago. As you lie there, perfectly still, you might imagine that very pulse moving through the wires of your home, a steady, invisible heartbeat that connects you to the rest of the world. This victory of alternating current set the stage for the magnificent journey that energy takes every single day. It transformed the landscape, leading to the creation of the long, slender wires that march across the countryside. These lines are the silent pathways of our modern life, stretching out across the quiet, misty fields at dawn, carrying the breath of distant turbines toward the places where we live and sleep. They are the threads that sew our cities and towns together in a single, glowing tapestry, moving the power we need through the vast open spaces of the world, while we rest in the safety of our rooms. As the electricity leaves the place where it was born, perhaps a quiet dam or a field of turning turbines, it begins a journey that is both immense and incredibly fast. But before it can travel across the vast distances of the countryside, it must undergo a profound change. At the edge of the power station, the electricity passes through a device called a step-up transformer. This is a moment of quiet preparation. Here, the voltage, the pressure of the electrical flow, is increased to staggering levels, often hundreds of thousands of volts. It might seem strange to increase the pressure so much, but there is a gentle wisdom in this physics. When the voltage is very high, the actual amount of current needed to carry the same amount of power is much lower. And because there is less current flowing, there is less friction within the wires themselves. This means that very little energy is lost as heat. The electricity can glide through the long silver cables with almost no resistance, preserved and protected as it moves toward its destination. Picture these transmission lines now. They are held high above the ground by tall, silent towers that march in a steady line across the horizon. These towers are the sentinels of the landscape, standing perfectly still as the world sleeps around them. If you were to stand beneath one in the early morning, you might see the wires stretching out like delicate threads of silk against the pale, waking sky. In the quiet of dawn, a soft mist often clings to the ground, blurring the base of the towers so they seem to float above the earth. The wires themselves are long, graceful curves. In physics, this shape is called a catenary, the natural, relaxed arc that a heavy cord takes when it is suspended between 2 points. Even the wires are resting in their own way, hanging heavy and steady in the cool air. As the sun begins to rise, the first light catches the metallic surface of the lines, making them shimmer with a soft silver glow. They carry a tremendous amount of energy, yet they do so without a sound, save perhaps for a very faint, rhythmic hum that is easily lost in the rustle of the morning breeze. These lines cross over wide, empty plains, through deep forests, and over the shoulders of ancient mountains. They represent a silent connection between the wild, natural places where energy is gathered and the cozy, lived-in places where it is used. For miles and miles, the electricity travels at nearly the speed of light, a focused and invisible force moving through the stillness. As the landscape begins to change, the wide, open fields give way to the gentle outskirts of a town. The tall towers begin to step down, becoming smaller and more frequent. The vast, high-voltage journey is nearing its end, and the energy begins to prepare for a more intimate setting. It moves away from the misty, wild horizons and begins to follow the curve of the roads, drawing closer to the neighborhoods where the lights are just beginning to flicker on in the windows of homes. The great, soaring journey across the world is slowing down, transitioning from the grand scale of the wilderness to the quiet, familiar rhythm of the local streets. As the high-voltage lines reach the edge of your town, they arrive at a place of quiet transition called a substation. You may have seen these before. Neat, fenced-in areas where the complexity of the power grid is organized into a series of sturdy silver structures and large, weather-beaten gray boxes. These boxes are the transformers, the silent translators of the electrical world. Their job is vital and incredibly simple in its elegance. They take the immense, high-pressure energy from the long-distance lines and step it down to a level that is safe and useful for our everyday lives. Inside a transformer, there are no moving parts, no gears turning, and no engines firing. Instead, there is only the quiet, invisible dance of magnetic fields. Two coils of wire sit close to one another, wrapped around a common core of iron, but they do not actually touch. When the high-voltage current flows through the first coil, it creates a pulsing magnetic field that reaches out and breathes life into the second coil. Because the second coil has fewer turns of wire than the first, the voltage is reduced, transformed into a gentler current that is ready to enter the neighborhood. If you were to stand near one of these substations in the stillness of the night, you would hear a very specific sound, a deep, resonant, and unwavering hum. This is often called the mains hum. It isn't the sound of friction, but rather the sound of the transformer's iron core physically reacting to the electricity. As the alternating current flows back and forth 60 times every second, the magnetic field causes the iron to expand and contract by a microscopic amount. This rhythmic stretching of the metal creates a low-frequency vibration in the air. It is a comforting, steady sound, a sonic reminder of the world's hidden pulse. Take a slow, deep breath now, and imagine that low, grounding hum. Let it settle into the background of your mind, a constant and reliable rhythm that mirrors the steady rise and fall of your chest. Just as the transformer hums with the effort of bringing energy to your door, you can let go of your own efforts, allowing your body to become heavy and still. There is a profound peace in things that work perfectly and quietly, tucked away from view. From the substation, the electricity travels along the familiar wooden or concrete poles that line your local streets. These lines are much lower to the ground, threading through the branches of trees and providing a resting place for birds in the evening. The energy is now at a mid-level voltage, but it still has one more transformation to undergo before it can safely enter your room. On the poles near your home, or perhaps tucked into a green metal box on the sidewalk, is one final, smaller transformer. This is the last gatekeeper. It brings the voltage down one more time to the standard level required by your lamps, your chargers, and your heaters. It is here that the journey becomes truly personal. A single insulated wire, often called a service drop, stretches out from the pole, reaching through the air like a steady hand toward the side of your house. It moves past the eaves of the roof, following the architecture of the building, and disappears into a small weatherhead. The electricity has officially arrived. It has crossed mountains and plains, been stepped up and stepped down, and now it waits silently behind the plaster and wood of your walls. It is no longer a wild force of nature or a high-voltage traveler. It has become a quiet guest in your home, ready to provide light and warmth at the flick of a switch, flowing through the hidden veins of the house while you drift toward sleep. Inside the quiet structure of your home, the electricity first gathers at a central point, the service panel, or what we often call the breaker box. Think of this as the heart of your home's electrical system, a place of distribution and watchful care. From this central hub, the power is divided into several different paths, known as circuits. The word circuit is quite beautiful when you think about it. It comes from the Latin word circuitous, meaning a going around. It implies a complete journey, a loop that must be closed for the energy to perform its work. In every room, behind the plaster and the paint, these loops of copper wire are waiting. For electricity to flow, it needs a continuous path from the power source, through an appliance or a bulb, and back again to the source. It is a graceful, never-ending cycle of giving and returning. When you flip a switch to the off position, you are physically creating a tiny gap in that loop. The electrons, those microscopic travelers we spoke of earlier, simply pause. They do not disappear. They wait patiently at the threshold of the switch, ready to resume their rhythmic dance the moment the path is restored. Along these hidden paths stand the circuit breakers, acting as silent, mechanical guardians of your peace. These devices are marvels of simple, reliable engineering. Inside a standard breaker, there is often a small strip of two different metals bonded together. As electricity flows through it, the metal stays cool and straight. But if too much current tries to rush through the wire, perhaps because too many devices are asking for energy at once, the metal strip begins to warm up. Because the two metals expand at different rates, the strip begins to curve. If it curves far enough, it triggers a spring-loaded latch that snaps the circuit open, instantly stopping the flow of power. It is a physical response to the laws of nature, a built-in safety measure that requires no thought and no complex computer. It is just physics, watching over you while you rest. Imagine these breakers now, standing in their dark metal cabinet in a quiet corner of your house, poised and ready to protect the integrity of your home. They ensure that the energy remains a helpful, gentle presence, never overstepping its bounds. As you settle deeper into your blankets, you might think of your home as a sanctuary, woven through with these protective loops. The wires are nestled safely within the studs of the walls, wrapped in layers of colorful insulation that keep the heat and the energy exactly where they belong. There is a profound sense of security in knowing that the architecture of your living space is designed to be both functional and incredibly safe. You are surrounded by a network of invisible support, a system that has been refined over a century to provide comfort without demand. The most common way we interact with this hidden network is through the gift of light. One of the many circuits in your home leads directly to the lamps and fixtures that illuminate your world. For a long time, the way we created this light was through a process as warm and steady as a glowing ember. As we move from the structure of the walls to the devices themselves, we find ourselves looking at the very thing that first invited electricity into our nighttime lives: the soft, golden glow of the traditional light bulb. This humble glass orb was the first bridge between the wild power of the lightning bolt and the quiet needs of a sleepy bedroom, turning the flow of electrons into a visible, comforting warmth that gently pushes back the shadows of the night. Think for a moment about the classic incandescent light bulb, that familiar pear-shaped glass orb that has defined our nights for over a century. Its name comes from the word incandescence, which literally means to glow with heat. It is a beautiful, simple process, almost like a miniature version of a glowing coal in a fireplace. Inside the bulb, a very thin wire called a filament stands ready, held up by small glass supports. When you flip a switch, you are sending a stream of electrons through this wire. But the wire is intentionally narrow and made of a material that resists the flow of electricity. As the electrons struggle to push through this tight space, they create friction at an atomic level, and that friction generates intense heat. The wire becomes so hot, reaching temperatures of thousands of degrees, that it begins to radiate a soft, golden light. Thomas Edison, in his quiet laboratories in the late 1800s, spent months searching for the perfect material for this filament. He needed something that would glow brightly for a long time without melting or breaking under the stress of the heat. He experimented with thousands of different substances, from silver and platinum to more organic materials like human hair and fishing line. Eventually, he found success with a delicate thread of carbonized bamboo. It was a triumph of persistence, a way to capture a small piece of the sun's brilliance and bring it safely indoors. To keep this glowing thread from burning up instantly, it had to be protected from the air. This is why the light bulb is made of glass. Inside that glass shell, the air is carefully pumped out to create a vacuum, or replaced with an inert gas like argon that doesn't react with the metal. Without oxygen, the filament cannot catch fire, It can only sit there in the stillness, vibrating with energy and casting its amber glow across the room. It is a tiny, controlled star, held captive in a bubble of glass, providing a steady, rhythmic presence in the corner of a room. Imagine a lamp beside your bed, fitted with one of these traditional bulbs. If you were to look closely at the filament, you would see a tiny, elegant coil, a spiral of tungsten that looks like a miniature spring. When the power is low, the glow is deep and warm, like the embers of a dying campfire. As you settle into your pillows, visualize that light now. See the warm, orange-yellow hue reflecting softly off the walls of a quiet, darkened room. Now, imagine a hand gently turning a dimmer switch. The bright yellow softens into a deep, rich amber. The amber slowly fades into a dull, rhythmic red, like a sunset retreating behind the horizon. Finally, the glow retreats entirely into the wire, leaving the room in a soft, velvety darkness that is perfect for rest. While this traditional bulb provided us with comfort and safety for many generations, it was also a very hungry device. Nearly 95% of the energy it used was shared with the surrounding air as heat, with only a small fraction actually turning into the light we needed to see. It was a cozy, radiant warmth, but as our understanding of the electron grew even deeper, we began to look for ways to create light that was cooler, more efficient, and even more enduring. We began to move away from the intense heat of the glowing filament and toward a new kind of magic found within the heart of solid materials. This shift took us from the flickering warmth of the past into the steady, cool brilliance of the modern era, where light is created not by the friction of heat, but by the quiet, effortless movement of electrons within a crystal. The transition from the intense heat of a filament to the cool, quiet world of the semiconductor marks one of the most peaceful shifts in our history with light. This is the realm of the light-emitting diode, or the LED. Unlike the traditional bulb, which requires a struggle between electricity and metal to create a glow, the LED operates with a subtle, effortless grace. It belongs to a class of materials known as semiconductors, substances like silicon or gallium that sit in a mysterious middle ground, neither fully conducting electricity like a copper wire, nor blocking it entirely like a piece of rubber. Imagine these semiconductors as two different landscapes meeting at a quiet border. On one side, there is a surplus of tiny electrons ready to move. On the other side, there are what scientists call holes, spaces where an electron is missing, like empty seats in a theater waiting for an occupant. When a gentle current is applied, the electrons begin to travel toward that border. As an electron reaches the other side and drops into an empty hole, it releases a tiny, microscopic burst of energy. In an old-fashioned light bulb, that energy would be mostly lost as heat. But in the specific, clever architecture of an LED, that energy is released as a pure, clean photon of light. Because this process doesn't rely on friction or extreme temperatures, the LED remains remarkably cool to the touch. It is a cold light, a serene light that does not waste its strength. If you were to reach out and rest your finger against a glowing LED, it would feel barely different from the air around it. This efficiency allows these tiny components to last for decades, glowing steadily for tens of thousands of hours without ever growing tired or brittle. They do not burn out so much as they slowly, very slowly, fade over many years of faithful service. In the stillness of your room, you might notice the small, dim indicator lights on your various devices. Perhaps there is a soft, ruby-red dot on a television, or a tiny emerald-green light on a monitor. These are the quiet sentinels of the modern age. They don't flicker, and they don't hum. They simply hold their color with a steady, unwavering constancy. They are the smallest expressions of this technology, providing a sense of order and readiness without disturbing the deep peace of the night. Visualize that tiny point of light now, a single, soft pixel of color in the darkness. It is a reminder that even in the deepest quiet, a small, controlled flow of energy is at work, keeping things ready for the morning. As you breathe in slowly, appreciate the quiet efficiency of these modern wonders. They provide us with light that is as gentle as it is powerful. But for these lights and the devices they live within to work wherever we go, they need a way to carry their energy with them. We are no longer tied to the heavy wires in our walls for every source of power. To truly set our technology free, we needed a way to bottle up this electrical potential, to store the movement of electrons in a quiet, chemical reservoir that we could carry in our pockets or rest on our nightstands. This leads us away from the glow of the diode and into the silent, internal chemistry of the battery, where energy waits patiently in the dark, held in a delicate balance, ready to be called upon at a moment's notice. The battery is a miracle of quiet chemistry, a way to trap the essence of a current and hold it within a small, sleek frame. Most of the devices we rely on today, the phone on your nightstand, the laptop on your desk, or the watch on your wrist, depend on the lithium-ion battery. To understand how it works, imagine a very thin, very organized sandwich of materials. On one side, we have a cathode, and on the other, an anode. In between is a specialized liquid or gel called an electrolyte, which acts as a bridge. When you plug your device into the wall at the end of the day, you are initiating a silent, internal migration. The electricity from your home provides the gentle pressure needed to push lithium ions, tiny, positively charged particles, away from their resting place in the cathode. They move through the electrolyte, drifting across the internal divide like swimmers crossing a calm, dark pool. They eventually reach the anode, where they nestle into the microscopic gaps of a carbon structure, often made of graphite. They stay there, tucked away, holding on to the potential energy you've given them. This is the filling up of the battery. There is no sound, no mechanical friction, and no outward sign of the work being done. Just the persistent, orderly movement of ions finding their place for the night. As you lie there, your body is also in a state of replenishment. Just as the ions in your phone are settling into their overnight home, your own systems are beginning the deep work of restoration. There is a beautiful symmetry in this. While the world outside slows down and the lights grow dim, these internal processes continue with a quiet, dedicated rhythm. The battery doesn't create electricity out of nothing. It simply stores the ability to create a flow later. When you wake up and unplug the device, the process reverses. The lithium ions naturally want to return to their original side of the sandwich. As they flow back toward the cathode, they release the energy that powers your screen, your speakers, and your connection to the world. It is a cycle of tension and release, of storage and use, repeating hundreds of times over the life of the device. Think of the incredible stability required for this. The materials must be pure, the layers incredibly thin, and the movement perfectly controlled to ensure safety and longevity. It is a testament to human ingenuity that we can contain such power in a device that fits in the palm of a hand. We have learned to mimic the way the universe stores potential, creating our own miniature reservoirs of energy. But as we marvel at these human-made wonders, we might also realize that we are not the first to use electricity in such a sophisticated way. Long before the first battery was ever assembled in a laboratory, nature had already perfected the art of the electrical signal. In the quiet of the night, as your heartbeat slows and your breathing becomes deep and regular, you are participating in a much older form of electrical engineering. We often think of electricity as something found only in wires and sockets, something external to our lived experience. But in truth, we are electrical beings. Every thought you have, every movement of your muscles, and every beat of your heart is powered by the movement of ions across the membranes of your cells. The same fundamental principles that allow your phone to hold a charge are at work within your own body, guiding the signals that keep you alive and dreaming. The transition from the world of copper and lithium to the world of biology is a seamless one, for the laws of physics do not change when they enter a living system. We are part of a vast, interconnected web of energy, where the same particles that power the stars and the cities also power the delicate dance of our own internal chemistry. Let your mind drift now from the plastic and metal of your devices to the soft, rhythmic pulse of your own existence. We are moving away from the machines we have built and into the quiet, invisible electricity of the natural world, starting with the very vessel that carries you through your life. Imagine your nervous system as a vast, intricate network of living wires, woven through every inch of your being. But unlike the copper cables in your walls that carry a constant stream of electrons, these biological wires are made of specialized cells called neurons. They communicate through quick, shimmering pulses of energy that are much more fluid and organic. This is bioelectricity, the spark of life that allows you to feel, to think, and to exist in this very moment. To understand how your body generates its own power, we have to look at the microscopic level, at the thin membrane that surrounds every one of your cells. On this surface, there is a remarkable mechanism known as the sodium-potassium pump. It sounds like a piece of industrial machinery, but it is incredibly delicate and silent. Imagine billions of tiny microscopic gates working tirelessly. These gates are constantly pumping sodium ions out of the cell and pulling potassium ions in. This process creates a slight difference in electrical charge between the inside and the outside of the cell, much like the positive and negative terminals of a battery. This difference in charge is called a resting potential. It is a state of quiet readiness, a reservoir of stored energy waiting for a signal. When a nerve needs to send a message, perhaps a signal to relax a muscle, or a thought that drifts through your mind, those gates suddenly open. The ions rush through the membrane seeking balance and create a wave of electrical change that travels rapidly down the length of the nerve. This is what scientists call an action potential. It is a tiny, localized spark that moves like a ripple across a pond, carrying information from your toes to your brain and back again. Every sensation you experience is translated into this electrical language. The softness of your pillow, the coolness of the air on your skin, the very sound of my voice, all of these are converted into electrical impulses by your sensory nerves. Your brain is a masterpiece of this bioelectrical processing, a quiet internal landscape where billions of neurons fire in a complex, beautiful harmony. Even now, as you prepare for sleep, your brain's electrical activity is shifting. The fast, jagged waves of the waking day are beginning to stretch out, becoming the slow, rolling oscillations of deep rest. Take a slow, deep breath and feel the incredible stillness of this system at work. You do not have to command your nerves to fire or your cells to maintain their charge. Your body manages this complex electrical grid with perfect, silent efficiency. As you lie there, notice the gentle, persistent pulse in your body. It is the most reliable rhythm you have ever known. This pulse is the result of a very specific electrical signal, one that originates in your chest and radiates outward to your very fingertips. While the brain handles the complex data of your thoughts, your heart relies on a much more singular, rhythmic electrical command, a steady drumbeat that has been firing since before you were born, guiding you through every moment of your life. Feel that rhythm now, the soft thrum of your own internal engine, as we move closer to the source of that steady, life-giving spark. This steady internal drumbeat is governed by a small but powerful group of cells called the sinoatrial node. It sits quietly in the upper part of your heart, acting as your body's natural, biological pacemaker. While your brain is the center of your thoughts and your nerves are the messengers of your senses, the sinoatrial node is the tireless timekeeper of your life. It is the conductor of a silent, rhythmic orchestra, ensuring that every beat happens at exactly the right moment, with exactly the right strength. Imagine this tiny node as a soft, glowing point of light within you. Every second or so, it releases a gentle pulse of electricity. This isn't a jarring shock, but a smooth, flowing wave of energy. It travels through the walls of the heart, causing the muscles to contract in a perfectly timed sequence. First, the upper chambers squeeze gently, pushing blood downward. Then, a fraction of a second later, the lower chambers follow, sending life-giving oxygen to every corner of your body, from the tips of your toes to the crown of your head. It is a dance of physics and biology, a loop of energy that never tires, repeating its cycle over 100,000 times every single day. As you lie there, you can feel the profound reliability of this system. There is a deep sense of security in knowing that your body knows exactly how to keep itself in motion while you rest. You do not need to monitor the rhythm or check the timing. The sinoatrial node manages it all, instinctively adjusting the pace as you drift deeper into relaxation. As your breathing slows and your muscles let go of the day's tension, this internal clock recognizes the shift. It gently lowers the tempo, slowing the heartbeat to a peaceful, resting crawl that mirrors the stillness of the room around you. Take a slow, deep breath and simply listen to that internal quiet. This electrical circuit is self-sustaining and incredibly resilient. It is an ancient design, one that has been perfected over millions of years. It serves as a constant reminder that you are a part of a much larger, living world, where electricity is not just something we find in copper wires or glass bulbs, but the very spark that defines what it means to be alive. This spark is not limited to the human form. Across the entire animal kingdom, nature has found ingenious ways to harness these tiny electrical currents. While we use electricity primarily to maintain the steady rhythm of our hearts and the movement of our thoughts, Other creatures have taken this fundamental force and adapted it for even more extraordinary purposes. In the hidden depths of the world's rivers and oceans, there are beings that have evolved to use electricity not just as an internal signal, but as a way to perceive and interact with the dark, mysterious world around them, turning their very bodies into living instruments of energy. As we move from the internal rhythm of the human heart into the vast, cool waters of our planet, we find that some creatures have mastered electricity in ways that seem almost like a quiet, natural magic. In the deep, slow-moving rivers of South America, there lives a creature that has become a legend of the natural world, the electric eel. Scientists have recently identified a specific species called Electrophorus voltae, which holds the record for the strongest bioelectric discharge ever recorded in the animal kingdom. It is a living testament to the sheer potential stored within the biological form. But these creatures do not use their power with aggression. Rather, it is their primary way of communicating with and understanding a world where light rarely reaches. To understand how they do this, imagine the eel's long, slender body as a living battery. Inside, it carries thousands of specialized cells called electrocytes. These were once ordinary muscle cells, but over millions of years of evolution, they changed their purpose. They no longer contract to help the eel swim. Instead, they act as tiny containers for electrical charge. When the eel wants to perceive its surroundings, it triggers these cells to release a very faint, gentle pulse of electricity into the surrounding water. This low-voltage signal creates an invisible field around the fish. As it glides through the dark, murky water, any object, a smooth river stone, a tangled root, or another living being, distorts that electrical field. The eel's sensitive skin detects these tiny changes, allowing it to map its environment with incredible precision, even in total darkness. It is a soft, constant conversation between the creature and the river, a way of feeling the world through the movement of electrons rather than the reflection of light. Take a moment now to settle deeper into your pillows, letting your limbs feel heavy and relaxed. Imagine yourself drifting in a similar way, not in a river, but in a space of perfect, cool stillness. You are floating effortlessly, supported by the soft weight of your blankets. Like the water around the eel, the air in your room is quiet and calm. There is no need to see or do anything. You can simply feel the peacefulness of the space around you. Much like the eel senses the gentle, rhythmic currents of its home. Notice the coolness of the air on your skin and the absolute safety of the dark. When the eel needs to hunt or protect itself, it can synchronize all those thousands of electrocytes to fire at exactly the same microsecond. This creates a much stronger surge of energy, a sudden, powerful flash that can reach over 800 volts. It is a remarkable feat of biological engineering, a living creature producing a spark that rivals the power coming from a household outlet, all managed by the quiet intent of its nervous system. Yet, even this impressive display is small compared to the vast electrical forces that gather high above our heads. The same principles of charge and release that the eel uses in the river are also at work in the very air we breathe, though on a scale that is truly monumental. As we leave the silent, hidden depths of the water and look toward the distant horizon, we begin to see how energy builds up in the atmosphere, waiting for the right moment to bridge the gap between the Earth and the heavens. The quiet, rhythmic pulse of the river is about to be answered by the grand, sweeping power of the sky, where electricity reveals its most dramatic and beautiful form. As we lift our gaze from the hidden depths of the river to the vast expanse of the twilight sky, we find that the same invisible forces are at play on a scale that is truly breathtaking. While the electric eel creates its own small, shimmering field in the water, the atmosphere above us is a grand celestial laboratory, constantly stirring with the movement of energy. Imagine for a moment a towering summer cloud, a soft mountain of white and gray rising miles into the air. Within this giant structure, a delicate and powerful dance is taking place. A silent collision of particles that mirrors the static spark of a finger touching a doorknob, but magnified 1,000,000 times over. Inside these clouds, the air is never truly still. Strong currents of warm air rise upward, while cooler air sinks toward the Earth, creating a rhythmic cycle of motion. As these currents move, they carry with them millions of tiny ice crystals and soft, slushy pellets of frozen water known as graupel. In the freezing heights of the atmosphere, these particles are constantly bumping into one another. The smaller, lighter ice crystals brush against the heavier graupel, and in this gentle friction, something remarkable happens. Electrons are knocked loose and transferred from one particle to another, much like the way amber attracts dust after being rubbed with silk. The lighter ice crystals, now carrying a positive charge, are swept toward the very top of the cloud, while the heavier, negatively charged graupel settles near the base. This separation creates a tremendous electrical tension, a quiet, invisible pressure building between the sky and the ground below. As the bottom of the cloud becomes heavily negative, it pushes away the electrons on the Earth's surface, leaving the ground beneath it positively charged. This positive shadow follows the cloud as it drifts across the landscape, reaching up through the tops of trees, the peaks of mountains, and the roofs of quiet houses, yearning to reconnect with the sky. When the tension becomes too great to hold back, the air itself, which usually acts as a soft insulator, briefly breaks down. A faint, invisible path called a stepped leader begins to snake down from the cloud in jagged pulses, searching for the easiest way to reach the Earth. At the same time, a streamer of positive charge reaches up from the ground to meet it. When they finally touch, the circuit is completed, and a brilliant surge of energy travels back up the path. This is the return stroke, the part of the lightning flash that our eyes actually see. It is a sudden, luminous bridge that balances the scales of the atmosphere in a fraction of a second. As you lie here in the stillness of your room, you might imagine the distant, muffled rumble of a summer storm far off on the horizon. To the ears of someone tucked safely under warm blankets, thunder is not a sharp or startling sound, but a low-frequency vibration that hums through the air. This sound is created because the lightning bolt is incredibly hot, 5 times hotter than the surface of the sun. This intense heat causes the air around the bolt to expand and contract with incredible speed, creating a pressure wave that travels for miles. By the time it reaches you, it is softened into a gentle, rolling growl, a reminder of the immense power of nature being released and neutralized in the distance. Take a slow, deep breath, feeling the air move in and out of your lungs with the same rhythmic ease as the rising and falling currents of the sky. There is a profound sense of safety in hearing a storm from far away. The sound of rain tapping softly against the window and the low vibration of the clouds only serve to make your bed feel warmer and more secure. You are a quiet observer of this grand, global balancing act. This magnificent display of lightning is more than just a passing weather event. It is a vital part of the way our planet maintains its equilibrium. Each flash of lightning across the globe acts as a pulse, a way for the Earth to regulate its own internal energy. It is as if the planet itself is breathing, using these sparks to stay in constant contact with the space surrounding it. This connection between the ground beneath us and the air above is not a series of random accidents, but part of a vast, invisible system that encompasses the entire world. As we settle deeper into the quiet of the night, we can begin to see that the Earth itself functions like a massive, living battery, constantly replenishing its charge through a silent, global circuit that never stops flowing. Imagine for a moment that the air around you is not just empty space, but a soft, electrified blanket that wraps around the entire world. This invisible network is known to scientists as the Global Atmospheric Electrical Circuit, and it is perhaps the largest and most silent machine in existence. To understand it, you can think of the entire planet as a vast, spherical battery. The Earth's surface acts as the negative terminal, while the ionosphere, a high, thin layer of the atmosphere, beginning about 37 miles above your head, acts as the positive terminal. Between these two great layers, the air serves as a gentle insulator, but it is not a perfect one. It allows a very faint, very steady current to trickle down from the sky to the ground at all times, even in the most peaceful, sun-drenched meadows or the quietest, moonlit forests. This current is so subtle that we cannot feel it, yet it is ever present, a constant drizzle of electricity that moves through the very air you breathe. While you lie there perfectly still, this global circuit is at work, maintaining the delicate balance of our world. You might wonder how this battery stays charged, since that tiny current is always draining energy toward the ground. The answer lies in the thousands of thunderstorms that are happening across the planet at any given second. While your corner of the world is silent and calm, there are always roughly 2,000 storms active elsewhere, acting as giant natural generators. They pump energy back up into the ionosphere, keeping the global battery topped up and the circuit flowing in a continuous rhythmic loop. It is a beautiful thought to realize that the planet is breathing with a soft electrical charge. Every lightning strike we discussed is a heartbeat in this system, a quick pulse that helps keep the Earth's electrical field alive. In the fair weather where you are now, the air is calm, but it is still part of this magnificent dance. The current here is slow and patient, moving with the same unhurried grace as your own breathing. If we could see these fields, the Earth would look like a glowing jewel, encased in a shimmering protective shell of energy that pulses with the collective power of every storm on every continent. Take another slow, deep breath, and let your body sink even further into the softness of your bed. As you exhale, imagine the tension leaving your muscles, just as the Earth gently releases its charge into the ground. You are part of this circuit, a quiet inhabitant of a world that is always connected, always balanced, and always replenishing itself. The same forces that power the grandest storms are, at this very moment, maintaining a peaceful equilibrium all around you. As we look up from the soil and the trees, past the clouds where the lightning resides, our journey takes us higher still. We move beyond the lower atmosphere, traveling upward into the thinning air where the Earth's electrical field begins to meet the vastness of space. Here, the air becomes rarer, and the influences of the sun and the stars begin to paint the sky with colors we rarely see from the ground. We are leaving the familiar world of rain and wind behind, moving toward the very edge of our planet's reach, where the invisible shield of the magnetosphere stands guard against the silent winds of the cosmos. As we drift higher, we reach the upper limits of our atmosphere, a place where the air is so thin it feels like a soft whisper. Here, at the very edge of the world, we witness one of the most beautiful displays of electricity in the entire solar system. The Aurora Borealis in the north and the Aurora Australis in the south. These dancing lights are the visual signature of our planet's relationship with the sun, a silent dialogue written in color across the night sky. To understand the aurora, we must imagine the sun not just as a source of light, but as a source of constant, invisible energy. The sun is always breathing out a stream of charged particles known as the solar wind. This wind consists of electrons and protons traveling at millions of miles per hour across the cold, dark void of space. When this solar wind reaches Earth, it encounters our magnetosphere, that protective magnetic bubble we spoke of. Most of the time, this shield deflects the solar wind, guiding it around us like water flowing around a smooth stone in a stream. However, near the north and south poles, the magnetic field lines curve inward, creating a sort of funnel. Some of the sun's charged particles are caught in these funnels and pulled down toward Earth's upper atmosphere. As they descend, they begin to collide with the gases that make up our air. This is where the magic happens. When a high-energy electron from the sun strikes an atom of oxygen or nitrogen in our atmosphere, it transfers some of its energy to that atom, exciting it. To return to its normal, calm state, the atom must release that extra energy, and it does so by emitting a tiny flash of light. It is very much like how a neon sign works. In a sign, electricity is passed through a tube filled with gas, causing the gas to glow with a steady, vibrant hue. In the sky, the atmosphere itself becomes the tube, and the sun provides the electricity. Because our atmosphere is made of different gases at different heights, the colors of the aurora change. Oxygen atoms, about 60 miles above us, produce the most common color, a haunting, brilliant green. If the oxygen is even higher up, nearly 200 miles high, it can glow a deep, rare red. Nitrogen, on the other hand, produces beautiful shades of blue or a delicate purplish pink along the lower edges of the shimmering curtains. Take a moment now to visualize these lights. Imagine you are lying in a wide, open field under a vast, dark sky. Above you, great curtains of soft green light begin to unfurl. They don't move quickly. They wave slowly, like silk fabric caught in a very gentle breeze. They pulse with a rhythmic, liquid grace, fading in one spot only to brighten in another. There is no sound, only the profound silence of the stars and the gentle, waving motion of the light. As you watch these colors drift across the velvet darkness, feel your own body becoming heavier and more relaxed. Each wave of light in the sky is like a slow, deep breath. The green light expands, then softly contracts, matching the steady rise and fall of your chest. The universe is vast and full of energy, yet here, at the edge of our world, that energy is transformed into something peaceful and breathtakingly beautiful. You are safe beneath this glowing canopy, protected by the very magnetic fields that create such wonder. The auroras remind us that electricity is not just something we generate in power plants or store in batteries. It is a fundamental part of the cosmic environment. It flows from the sun, interacts with our planet, and paints the darkness with the colors of life and protection. But as we watch these curtains of light fade into the distance, we realize that the journey of electricity extends even further than the reaches of our atmosphere. Beyond the shimmering greens and purples of the aurora lies the true deep space, a place of absolute stillness and cold, where different kinds of power are needed to light the way. We leave the warmth of the Earth's breath behind now, turning our gaze toward the small, lonely voyagers we have sent out into the great dark, and the remarkable ways they carry their own spark of energy into the unknown. As we move past the glowing veils of the aurora, the air thins and eventually disappears altogether. We enter the profound silence of the vacuum, a place where the sun's warmth becomes a distant memory and the familiar comforts of our atmosphere are left far behind. The silence of deep space is unlike any silence we know on Earth. It is a stillness that stretches for billions of miles in every direction. Out here, the sun is no longer a warm golden disk that fills the sky. It is merely the brightest star in a field of infinite, cold diamonds. For the robotic explorers we send into this great dark, the traditional ways of gathering power, like the solar panels that catch the sun's rays near Earth, eventually become ineffective. The light is simply too weak to provide the energy needed to keep their instruments alive. To survive in the cold reaches of the outer solar system and the interstellar void beyond, these lonely voyagers carry a different kind of spark. They rely on something called a radioisotope thermoelectric generator, or an RTG. While the name may sound complex, the concept is as simple and reliable as a steady heartbeat. Inside these generators, there are no burning fires, no moving pistons, and no spinning turbines. Instead, there is a small amount of material that is naturally radioactive, such as plutonium-238. As these atoms slowly and naturally decay over many decades, they release a gentle, constant, and predictable heat. This heat is then converted directly into electricity through a beautiful and quiet phenomenon of physics. By placing two different types of metal together and keeping one side warm with the decaying material while the other side is cooled by the freezing vacuum of space, a flow of electrons is created. It is a silent, motionless process. There are no gears to wear out, no joints to lubricate, and no fuel to pump. It is a quiet, internal glow that provides a steady stream of power for 40, 50, or even 60 years at a time. It is perhaps the most peaceful way we have ever devised to generate electricity, a simple exchange of heat for light in the middle of the frozen dark. Think of the Voyager 1 and Voyager 2 spacecraft, launched in the late 1970s. They are now the furthest human-made objects in existence, having crossed the invisible boundary where the sun's magnetic influence ends and the interstellar void begins. They are moving through a realm of absolute shadow, billions of miles from the nearest light bulb or power line. Yet their hearts are still warm, in the crushing cold of the void, where temperatures hover just above absolute zero. Those tiny generators are still humming. They are sending faint, silver whispers of data back across the emptiness, telling us what the edge of our solar system looks like. Take a slow, deep breath and imagine the Voyager probe now. It is a small, silver speck against the velvet blackness of the cosmos. It doesn't struggle or strain. It simply glides, powered by the slow, rhythmic breakdown of atoms that have been warm since the day they were forged. It is a peaceful vigil. The probe is a silent witness to the vastness of the universe, its sensors clicking softly as it measures the thin, invisible particles between the stars. It is a reminder that even in the coldest, most isolated places, the laws of physics provide a way to maintain a spark of light and a sense of purpose. As you lie there, nestled in the warmth of your blankets, you might feel a similar sense of steady, quiet energy. Just as the Voyager carries its own heat through the cold, you have your own internal rhythm, a warmth that persists, a breath that continues, and a heart that beats reliably without you ever having to tell it to. You are your own self-sustaining system, protected and calm, drifting safely through the quiet hours of the night. The heat that powers these distant probes is a small, controlled echo of a much grander process. The radioactive elements we use in space are like embers left over from a much larger, ancient fire. They are the heavy atoms created long ago in the spectacular lives and deaths of the stars themselves. To truly understand where all energy begins, the light of the aurora, the power in our wires, the heat in our bodies, and the spark in the heart of a spacecraft, we must look past our own neighborhood. We must turn our gaze toward the celestial furnaces that dot the night sky, for it is there, in the hearts of the stars, that electricity and light are born from the very fabric of matter. Imagine the night sky above you, a vast tapestry of distant, diamond-bright lights. Each one of those points is a sun, a massive, swirling sphere of gas held together by its own immense gravity. Within the heart of these giants, a process occurs that is so powerful it provides the light and warmth for entire solar systems. This is nuclear fusion, the ultimate source of almost all the energy we have ever known. It is the engine of the universe, a silent and steady forge that has been burning for billions of years. In the core of a star, like our own sun, the pressure is unimaginable. It is so intense that atoms of hydrogen, the simplest and most abundant element in the universe, are crushed together. They are squeezed with such force that they overcome their natural tendency to push away from one another. In a moment of transformative union, two hydrogen nuclei fuse to become one nucleus of helium. In that tiny microscopic marriage of atoms, a small fraction of their mass is lost, converted into a burst of pure, radiant energy. This is the secret of the stars. They turn the very fabric of matter into light. This energy begins its life as a gamma ray, a high-energy photon born in the sun's crushing center. But its journey to the surface is not a straight line. The sun is so dense that the photon cannot simply fly out. Instead, it enters what scientists call a random walk. It travels a fraction of an inch before bumping into another atom, being absorbed, and then re-emitted in a different direction. It zigzags, bounces, and wanders through the sun's interior for tens of thousands, perhaps even hundreds of thousands of years. It is a slow, patient migration, a long-distance journey through a sea of light and heat. Eventually, after millennia of wandering, the photon reaches the sun's outer layer, the photosphere. Suddenly, the way is clear. It leaps into the vacuum of space, traveling at the speed of light. In just over 8 minutes, it crosses the 93 million miles to reach our planet. It lands softly on a leaf to help a tree grow, or perhaps it strikes a solar panel to light a lamp in your home. It is a journey that began before human civilization was born, finally finding its rest as a gentle glow or a flicker of power. As you lie here, contemplate the sheer scale of this process. The stars are so vast and powerful, yet they are so far away that their light arrives only as a soft, comforting twinkle. There is a profound sense of safety in this distance. The universe is a place of immense power, but it is organized and balanced. You are a small, precious part of this grand design, tucked away on a cool, quiet planet that is perfectly positioned to receive just the right amount of that celestial warmth. Take a slow, deep breath, and let the thought of that ancient, starlight-born energy wrap around you like a soft, luminous blanket. But while we look to the stars for the origin of our light, we don't always have to look up to find the power that sustains us. Sometimes, the same heat that powers the stars, the heat of creation and the movement of atoms, is stored right beneath our feet. As we drift back down from the cosmic heights, we return to the solid ground of our own world, where the earth itself holds on to a deep, primordial warmth that we are only just beginning to fully understand. This heat, trapped within the heart of our planet, offers us another way to power our world, one that is as steady and reliable as the ground we walk upon. Deep beneath the surface of the earth, far below the soil where roots reach and stones rest, there is a profound and ancient warmth. While the stars above burn with the fire of fusion, our own planet carries a remnant of that same cosmic heat within its core. This is geothermal energy, the earth heat, a silent, steady power that has been radiating from the center of our world for billions of years. It is a gift from the very beginning of time, a mixture of the heat left over from the Earth's violent formation and the slow natural decay of radioactive elements like uranium and thorium deep within the mantle. Imagine the Earth not as a cold rock, but as a giant, well-insulated vessel. The crust we live upon is merely a thin, cool shell. Below it, the temperatures rise steadily, becoming a glowing, pressurized reservoir of energy. In certain places where the crust is thin or fractured, this heat finds its way toward the surface. It warms the groundwater, creating hidden rivers of steam and boiling pools that have been used by humans for thousands of years. To tap into this energy, we look for these thermal hotspots. We drill deep into the rock, reaching down into the pockets where the Earth's breath is hottest. When water is pumped down into these depths, it meets the scorching rock and flashes instantly into steam. This steam, under immense pressure, rises back to the surface through insulated pipes, carrying the Earth's internal fire with it. Just as the wind turns a turbine or falling water spins a wheel, this subterranean steam is channeled into a generator. It pushes against the blades of a turbine with a rhythmic, powerful force, converting the heat of the deep earth into the electricity that lights our bedside lamps. There is something deeply comforting about the nature of geothermal power. Unlike the wind, which may lull into a breeze, or the sun, which sets every evening, the Earth's internal heat is constant. It is what engineers call base load power, a reliable, unceasing hum that never wavers. It is the heartbeat of the planet, a slow and steady pulse that provides a sense of absolute permanence. Close your eyes and imagine standing on the edge of a natural hot spring on a crisp, cool morning. The air around you is chilly. Perhaps there is a light frost on the grass, but the water before you is thick with rising mist. You can see the soft, white plumes of steam curling lazily into the sky, disappearing into the gray light of dawn. The water is a deep, clear turquoise, heated by the very rocks you stand upon. As you dip a hand into the water, the warmth is immediate and soothing, a direct connection to the molten heart of the world. It is a gentle reminder that even in the coldest environments, there is a source of warmth nearby, tucked safely away beneath the surface. This process of taking heat and turning it into motion, and then into light, is a beautiful demonstration of how energy flows through our lives. It is never truly lost. It simply changes its clothes, moving from the vibration of hot atoms deep in the crust to the spinning of a metal shaft, and finally to the silent flow of electrons. This constant transformation is governed by laws as old as the universe itself. As we contemplate the heat of the Earth and the way it moves upward to meet us, we begin to see the world not as a collection of separate things, but as a single, interconnected system of energy. This brings us to a fundamental truth about our reality: the idea that energy is an eternal traveler, always moving, always changing, but never truly disappearing. It is a concept that tethers the heat of the Earth to the light of the stars and the very breath in your lungs. This brings us to a fundamental pillar of physics, something known as the first law of thermodynamics. While the name might sound rigid or complex, the truth it holds is one of the most reassuring concepts in all of science. It is the law of conservation of energy. It tells us that in the entire vast expanse of the universe, energy can neither be created nor can it be destroyed. It can only change from one form into another. Imagine for a moment that the universe is a grand, silent room, and within that room is a specific, unchanging amount of light and heat. You can move the furniture, you can stir the air, you can turn a lamp on or off, but the total amount of energy remains exactly the same. It is a constant, a steady, unbreakable foundation upon which everything else is built. When you think about the electricity powering your home, you are witnessing this law in action. The light glowing from a soft bedside lamp isn't new energy. It is simply the energy of moving electrons being transformed into radiant photons and a tiny, comforting bit of warmth. The heat you feel beneath your blankets is energy that was once stored in the food you ate, which was once sunlight captured by a plant in a quiet field. This means that the energy currently keeping you warm and allowing your heart to beat has been around since the very beginning of time. It has traveled through the cores of ancient stars, across the cold vacuum of space, through our atmosphere, and into the soil. It has been the force of the wind, the weight of the rain, and the vibration of the earth. Now, for this brief and beautiful moment, it is the quiet power that sustains you. There is a profound sense of continuity in this. Nothing is ever truly lost. The universe does not let go of its power. It simply rearranges it. As you lie there, settling deeper into your pillows, you might feel a sense of peace, knowing that you are part of an eternal, recycling flow. The energy of the world is like a great, slow-moving river that never runs dry. It simply winds its way through different landscapes, sometimes as the roar of a distant waterfall, sometimes as the silent, invisible pull of a magnet, and sometimes as the quiet, steady current that brings power to your neighborhood. It is a cycle that never ends, a conservation that ensures nothing is ever forgotten by the laws of physics. Because energy is so precious and its laws so absolute, we have begun to develop more sophisticated ways to shepherd it through our modern world. We are moving away from the older, simpler ways of sending power in one direction and hoping it reaches its destination. Instead, we are creating what scientists call smart grids. These are like the nervous system of a city, highly sensitive, deeply intelligent networks that can feel where energy is needed and where it is in excess. By using sensors and digital communication, these grids ensure that the eternal energy of the universe is used with the utmost respect and efficiency. They watch the flow of electrons with the same care a gardener might watch a stream, making sure every drop of potential is directed exactly where it can do the most good, minimizing waste as we learn to live in harmony with the natural limits of our world. As we refine these systems, we move closer to a future where energy flows without friction, guided by a new understanding of how to let it move as freely as possible. As we peer into the quiet future of how we manage this energy, we find ourselves exploring the world of superconductors, materials that seem almost magical in their stillness. In our current world, even the most high-quality copper wires have what scientists call resistance. It is a very subtle form of internal friction. As electrons travel through a wire, they occasionally bump into the atoms of the metal, and these tiny collisions turn a small portion of the electrical energy into heat. It is a gentle, inevitable tax that nature takes on the movement of power. But in the world of the very cold, something extraordinary happens. Scientists have discovered that certain materials, when chilled to extreme temperatures, undergo a profound transformation. They become superconductors. In this state, the atoms inside the material settle into a perfect rhythmic alignment, almost as if they are holding their breath. The electrons no longer bump or jostle against their surroundings. Instead, they glide. They move through the material with absolutely zero resistance, like a skater on a lake of perfectly smooth glass that never ends. Imagine a small loop made of this superconducting material. If you were to start an electrical current flowing within that loop and then remove the power source, the electricity would not stop. It would not fade or flicker out. Because there is no resistance to slow it down, the electrons would continue to circle silently and perfectly for years, decades, or perhaps even longer. It is the closest thing we have to a perpetual motion of energy, a state of total harmony where nothing is lost to the environment. It is a vision of a future where power can be moved across entire continents without losing a single spark of its potential, delivered with total, hushed efficiency. As you think about that lack of resistance, that perfect, easy flow, Take a moment to check in with your own body. Often, without realizing it, we hold on to little pockets of resistance in our muscles. Perhaps it is a slight tightness in the jaw, or the way your shoulders are held just a fraction of an inch higher than they need to be. Just like those electrons in a superconductor, imagine letting all that resistance simply vanish. Let your muscles become soft and heavy, sinking into the mattress. Let the breath move in and out of your chest with no effort at all, a smooth and natural current of air. You are letting go of the friction of the day, allowing yourself to settle into a state of quiet, where your only task is to exist in this peaceful moment. This pursuit of efficiency isn't just for laboratories. It is a philosophy that already shapes how we interact with the world around us. We are learning to build a world that doesn't fight against itself, but rather one that supports the easy movement of the energy we need. By reducing the resistance in our technology and our homes, we make the journey of each electron a little bit shorter and a little bit quieter. This brings us back to the familiar spaces we inhabit, the walls of your room, the soft glow of a small indicator light, and the quiet, hidden pathways that bring power to your fingertips. We are beginning to see that our homes and our cities are not just collections of separate devices, but part of a much larger, synchronized rhythm that connects us all. This invisible connection ensures that while we sleep, the world remains gently powered and balanced. If you were to listen very closely in the deepest silence of the night, when the traffic has died away and the house has settled into its evening bones, you might hear it. A low, steady, almost imperceptible drone. It is not a noise, really, but more of a presence, a subtle vibration that exists just on the edge of hearing. This is the quiet hum of our civilization, the physical sound of the electricity we have been exploring. It is the mains frequency, a constant rhythmic pulse that serves as the heartbeat of the modern world. In most of the Americas and parts of Asia, this pulse beats 60 times every second, a frequency of 60 hertz. In Europe, Africa, and much of the rest of the world, it breathes a little more slowly, at 50 hertz. This number represents the speed at which the giant turbines in distant power plants are spinning. But the truly beautiful part of this science is the concept of synchronization. Across an entire continent, every single generator, whether it is a massive nuclear reactor, a spinning hydroelectric turbine, or a field of wind engines, is locked into the exact same rhythm. They are all coupled together by the invisible force of electromagnetism, spinning in perfect, absolute unison. Imagine the sheer scale of this harmony. From the furthest reaches of the coastline to the heart of the busiest city, every rotating machine connected to the grid is dancing to the same tempo. If one generator begins to slow down, even by a fraction of a percent, the rest of the grid feels the weight and gently pulls it back into time. It is a massive, collective effort of physics and engineering that ensures the power remains stable. This unified vibration travels through thousands of miles of wire, into substations, through transformers, and finally into the walls of your room. It is a song of synchronization, a reminder that while you are a single person resting in a quiet bed, you are connected to a vast, humming network that spans the globe. This hum is often the result of magnetostriction, a phenomenon where the magnetic fields inside transformers cause the metal cores to expand and contract ever so slightly, dozens of times a second. It is the sound of the equipment breathing. For many, This low-frequency drone acts as a form of industrial white noise, a comforting signal that the world is functioning as it should. It is the sound of safety, of a system that is being monitored and maintained by thousands of people while you drift toward sleep. As you lie there, let your own internal rhythm begin to synchronize with the peaceful stillness around you. Just as the power grid maintains its steady, reliable pulse, your body knows how to maintain its own gentle cycles. Your breath slows. Your heart finds a calm and easy pace, and your mind begins to let go of the complex frequencies of the day. You are part of this grand, synchronized world, but for now, your role is simply to be still. The world is carrying the weight of the current for you. The turbines are spinning, the magnets are dancing, and the grid is holding its steady 50 or 60 beat rhythm, all so that you can let go of the need to be productive. The hum of the world is a lullaby of the modern age, a soft mechanical reassurance that the light will be there when you wake, but that for now the darkness is a place of recharge and recovery. Feel the air in the room, cool and still, and notice how the silence seems to wrap around that distant, low hum, cushioning it and turning it into a blanket of sound. You are resting in the heart of a powered world, a world that has learned to harness the fundamental forces of the universe to create a space of comfort and warmth. The energy is there, tucked away in the walls, silent and waiting, as you prepare to cross the threshold into a deep and restorative quiet. Your journey through the wires and the stars is leading you back to the simplest, most essential state of all, the quiet current of a mind at rest. We have traveled a long way tonight, following the invisible threads of the electron from the very center of the atom to the furthest reaches of the glowing stars. It is a journey that began with the smallest building blocks of matter, those tiny, rhythmic particles that orbit in a silent dance, creating the fundamental charge that powers everything we know. We have seen how a simple piece of amber, rubbed by a hand in ancient Greece, revealed the first hints of this hidden force, and how that same spark now flows through the vast, complex networks that span our continents. From the first steady current of Alessandro Volta's chemical piles to the massive, spinning turbines of hydroelectric dams and wind farms, we have explored the many ways the universe shares its energy with us. We have visualized the invisible fields of magnetism that Michael Faraday used to bridge the gap between motion and power, and we have felt the warmth of the sun as its photons knock electrons loose in silent solar panels. We have walked through the history of the great currents, understanding how the alternating pulse of our modern grid allows energy to travel hundreds of miles through misty fields and over quiet mountains, just to reach the lamp beside your bed. The science of electricity is not just a story of wires and machines. It is a story of the natural world. We have looked at the lightning that crackles in the summer sky and the aurora that paints the poles in curtains of green and violet. We have even looked within ourselves, recognizing the delicate bioelectricity that allows our hearts to beat and our minds to dream. Every thought you have had tonight, every breath you have taken, has been supported by the same fundamental forces that power the sun and the distant Voyager probes drifting through the silence of interstellar space. The world is a place of incredible order and beauty, held together by these quiet, energetic laws. And now, as our exploration comes to a close, you can feel that order reflected in your own body. The lights are low, the room is still, and the great mains frequency of the world is humming its steady 60-beat lullaby in the distance. The engineers are watching the monitors. The turbines are turning with a reliable weight, and the grid is stable. Everything is as it should be. The world is powered, and it is safe. Take a final, slow, deep breath. As you exhale, let the last of your curiosity dissolve into the softness of your pillow. The journey of the electron has led us back here to this moment of absolute peace. You have learned of the power that moves the universe, and now you can use that knowledge to let go, knowing that the world will continue its steady, synchronized dance while you rest. The energy of the day has been transformed into the stillness of the night. The facts have been shared, the stories told, and the science has brought us to the threshold of sleep. There's nothing more to think about, nothing more to do. You are part of the great, quiet current of the cosmos, drifting effortlessly toward a deep and restorative rest. The universe is vast, the stars are bright, and the world is humming a song of safety just for you. Let the silence wrap around you now. Feel the weight of the blankets and the lightness of your mind. You are sinking deeper into the quiet, moving away from the world of movement and into the world of dreams. The power is there, tucked away, silent and waiting for tomorrow. But for now, there is only the dark, the warmth, and the peace. Sleep now. Deep, restful sleep. The lights are dim, the world is still. Sleep. Sleep.